question about electromagnets. So describe the construction of a simple electromagnet that is producing a magnetic field. You may draw a diagram to help you your answer. So the diagram here will achieve absolutely everything because an electromagnet is simply a coil of wire, otherwise known as a solenoid. So if we draw a coil of wire, there we go. And if you are drawing, then it's really useful to label up what you are doing. And then electromagnets need a core, so they need to have some kind of magnetic material at the core. Okay, so it doesn't actually matter which magnetic material you refer to. All right, the usual one to use is iron. So we have an iron core, or we could have anything that we would call magnetically soft. So anything magnetically soft, that means a material that can be magnetized easily and demagnetized easily, but iron is a really good example. So we have our solenoid wrapped around our iron core. But the key thing about electromagnets is that we need that clue there. There needs to be some kind of electricity. So we have to have going into our coil of wire, we need to have some kind of current flowing into it. Now you could demonstrate that by continuing your diagram and having any kind of source, so a battery or a power pack, but it needs to be a direct source. Okay, so it should be a DC current going in. You can, of course, do this in words, but sometimes diagrams are much easier to do. Here we're shown a proton moving through a magnetic field produced by an electromagnet. We've got the field in that grey shaded area, and we're shown from across that the magnetic field is acting into the page. We're asked to use the left-hand rule, so that's Fleming's left-hand rule, to determine the direction of the force acting on the proton. Now our proton is moving from left to right. So this may throw you off. You say, well, hang on, it's a moving charge. When I see the motor effect, it's normally a wire. But think about what happens in the motor effect. A wire is carrying a current, and a current is simply a moving charge. So this applies in exactly the same thing. So the direction of our proton from left to right, that is the same direction as conventional current. So you need to take your left hand and put your first finger, second finger, and thumb at 90 degrees to each other. Your first finger should point downwards towards your page because the magnetic field is going into the page. Your current is then traveling from left to right. So your second finger should be pointing from left to right. And when you do that, you will find that your thumb is left pointing upwards towards the top of the page. So upwards or top of page. Explain how the force on the proton changes as the proton moves through the magnetic field. You may add to the diagram to help you answer. So the key thing is, as long as that proton is moving, it is still going to experience a force. And that force will always be at 90 degrees to its direction of travel and the magnetic field. But as soon as it's experienced a force, its direction of travel has been altered. So the key thing here is that the force must always be at right angles to effectively to the proton's movement and therefore to the proton's velocity. So the force is always at right angles to its velocity. And because that moving proton is just a current effectively, so that force at right angles is going to cause the proton's direction to change. And the reason for that is because a moving proton is just the same as a current, and the size of that force isn't going to change. So we've got a few things here that we can say. You can see this is a 2-mark question, so you don't have to have all of these in there. But the main thing is that the size of the force doesn't change, but because that force is always at right angles to the movement of the proton, therefore, because the proton's direction is going to change, so is the direction of the force. So if you want to summarize that into 2 points, the idea of the size stays the same, but the direction of it will change as the proton moves. And then part 3 suggests why the velocity of the proton changes. So we're looking at velocity here. Think about velocity. It is a vector, okay? So it's a vector quantity, and that means it has a magnitude and a direction. So the reason that the velocity of the proton is going to change is because the direction changes. So the speed of the proton won't change because the size of the force isn't changing. It won't be getting faster or slower, but because it is changing direction, its velocity will be changing.